Hello and welcome to the Soil Notes. Forensic geology is the legal application of earth and soil science. So it's using characteristics of earth and materials that have been transferred in between objects or locations. So tracking soil from the crime scene to another crime scene or from one location, like for instance the crime scene, and then it's found in the suspect's car. Transferring those soils will allow for a timeline of possible events. As far as the history of forensic geology, there's really four main key points throughout history that forensic geology has been used. So the first time it was ever mentioned was in a Sherlock Holmes novel, where they talked about soil and its composition, which had never been used before. So this was in the late 1800s. In 1893, a criminal investigator named Hans Gross wrote that there should be a study of dust, dirt on shoes, and spots on cloth. He observed that dirt on shoes can often tell us more about where the wearer of those shoes had been, more so than toilsome inquiries. Meaning that the person may lie, but the soil on their shoes would not. In 1904, Jörg Popp, a German forensic scientist, presented the first example of earth materials used as evidence in a criminal case, and that was during the strangulation of Eva Dersch. She was strangled by her then boyfriend, and he was found with her makeup underneath his nails. At the time, in 1904, it wasn't like you could go down to the supermarket and buy CoverGirl or Maybelline. At that time, you had to go to the chemist, which is the pharmacist, and they would actually make a specific combination of minerals for you to use as your makeup. So it was very individualized at that point. In 1910, Lockhart was most interested in the fact that dust was transferred from the crime scene to the criminal, and it was what helped him create his Lockhart's principle, which is that whatever you come in contact with, you will have a transfer of materials. Soil itself is any materials that cover the Earth's surface that are capable of supporting plant growth. The Earth itself is made up of 75% water, 15% deserts and mountains and polar ice caps, and then 10% of the Earth is actually suitable for agriculture, meaning that it's suitable to grow crops on. The formation of soil will depend on the following 6 things. What living organisms or living matter is in the soil, so plants, animals, microorganisms, if there's any inorganic materials in there, the climate that the soil is found at, what the parent materials are, so if it's granite or if it's limestone or slate, the relief, which is the slope and the landform itself, is it on the side of a mountain or is it on the flat of a plain? And the amount of time. The profile of the soil, you will have in layers, you will have the topsoil and then the subsoil, and then at the very bottom is the parent material. So the topsoil is what we see every day when we look at the ground. Okay? Subsoil is underneath that, and then the parent material is the hard part that you hit when you cannot dig any further. The composition of soil all has to deal with the diameter of the granule. So sand is the largest, then you have silt, which is smaller than sand, and clay, which is smaller than silt. And then you have the organic matter that is in there. The macronutrients you will find all over the earth in differing components or differing amounts. But the stuff that you find the most in soil is nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. If you are having a hard time growing things, you will often use fertilizer. Fertilizer is made up usually of these macronutrients because that is what's lacking in the soil or has smaller amounts in the soil for people to grow plants in. Micronutrients, these are found throughout the world. Some of these micronutrients will be in more pronounced amounts in certain places. So for instance, iron will give the soil a reddish color. Up in Sedona, we have a lot of iron in the soil. Okay, so in order to compare soils, soils can establish a relationship or a link between the crime or the crime scene, the victim, and the suspect. When you're comparing the soils between the samples, or comparing the samples of the soils, you need to make sure that all the samples are completely dry. So typically you will collect the soil and then you will dry them for 24 hours before performing any tests on them. The physical tests that you will look at, or the physical properties that you will look at, are the density of the soil, magnetism, particle size, and mineralogy. So what minerals are found in the soil. Chemical property-wise, you look for pH and then any other trace elements that are in the soil. The probative value of soil. The amount of soil on Earth is virtually unlimited, so we have a very wide distribution, but it changes over short distances. So what that means is that statistically speaking, if you're given a sample, you can narrow it down to an area of the Earth in which it came from. You can't narrow it down to a specific location, but you can narrow it down to a specific area. So you can say this soil comes from Arizona as opposed to North Dakota. Okay, but you can't say this came from the corner of Central and Camelback in Phoenix, but you can say it came from Arizona in general. The evidential value of soil can be excellent, especially if you have rare or unusual minerals in it, specific rocks that are found in only one location, or fossils, or if you have manufactured particles in it. Minerals are another aspect that you can find in soil. There are about 20 or so that are commonly found in soils. Most soil will contain only 3 to 5 of those 20, so you can narrow it down to a location. For instance, in the state we have zinc and copper as being the most. We have zinc and copper mines all over like Arizona. So those are the ones that you find the most often in our soil. Rocks in general are aggregates of minerals. There's natural types that are like granite or limestone or slate, and then there's man-made stuff, which is concrete. The 3 types of formations, so igneous, sedimentary, and metamorphic, those will play into what types of rocks you have. Fossils are the remains of plants and animals. They can help determine the age of the rocks, and they can help identify regions or locations based on what fossils are found in it. Palynology is the study of pollen and spores. It's important to know what plants are found in a given area and their dispersal pattern, so how they disperse their pollen. Do they use animals to carry their pollen from one plant to another, or do they disperse it into the wind for the wind to carry it? There's variation in size and weight between pollens. Not all pollen is yellow, even though that's the color that we most commonly associate with pollen. So knowing the pattern of plants in the area can tell you where people have been based on the pollen that is found on their clothing. Soil evidence in general is considered to be class characteristics, unless for some reason you have something that is super rare or unusual. So if you have a specific type of pollen or seed or fragment of something, that is found in the soil that can only be located in one area. Sand, on the other hand, is also found all over the earth, especially in coastal regions. It is particles with a grain diameter of 1/16 of a millimeter to 2 millimeters in diameter. The color and contents are dependent upon the parent rock and the surrounding plant and animal life. You have pretty much all different types of sand. This one here is usually continental shelf sand. This is usually the sand that we see the most often on our playgrounds and stuff, or in our beach volleyball pits. Black sand is found in Hawaii. There's very few spots on Earth that have black sand, so that is a rarer type of sand compared to the continental, which is found almost all over the United States. The composition is based on the material of the source. That's also what gives it its color. Texture is determined by the way the source was transported. So if the sand is on a beach and it's being hit by waves every day, you're going to have a sorting of the sand. You're going to have softer sand because it's being hit by water. So the different types of sand types. The continental sands, like I was talking about, what we have here is usually remnants of granite, so little particles of granite. The ocean floor sands are formed from volcanic material, and they're usually made out of basalt. So this is like down past the continental shelf. Okay. Carbonate sands are composed of various forms of calcium carbonate. You can find these closer to some geysers. The geysers typically will have a high carbonate, calcium carbonate composition, so you'll see those sands there. Tufa sands are formed when calcium ions from underground springs precipitate with carbonate ions in the salt water of a salt lake. So you find tufa sands, obviously at the Salt Lake in Utah, but Mono Lake in California also has tufa sands as well. The class characteristics of sand are the same as with soil. It is considered to be a class characteristic unless you have some sort of unusual ingredient or contaminant. That concludes the soil notes. Thank you for listening and have a great day.